Okay, now we're going to talk about finding the domain for a logarithmic function. And you will recall that the exponential function having base b has the range of all positive real numbers. So its inverse function, which is f of x equals log base b of x, has domain of all positive real numbers. See how when you're going from the main function to its inverse, you're going to swap range and domain. So here the range is all positive real numbers. Therefore, for the inverse function, which is the log function, it's going to have a domain of all positive real numbers. So if you happen to have a function which is logarithmic, but has another function of x inside the log, then you're going to take, in order to find the domain, you're going to take your inside function and set it greater than 0. So here are some examples. We want to find the domain for these three functions. Each of them are logarithmic functions. This one has base 5. This one is the common log, base 10. And this is the natural log, base e. So in order to find the domain, I'm going to set what's inside the log greater than 0. So here we get x plus 6 is greater than 0. And if we subtract 6 from both sides, we'll get that x is greater than negative 6. And so in interval notation, we can write that as the domain is minus 6 to infinity. Or in set builder notation, you can say the set of all x such that x is greater than negative 6. So either way is correct. Here, now we're going to set x minus 7 squared is going to be greater than 0. So x minus 7 squared is greater than 0, and this is a quadratic function. So in order to find the intervals where it's greater than 0, you need to find the x-intercepts. And the x-intercept is actually, in this case, to find the x-intercept, we set x minus 7 squared equal to 0, and we solve this. And if x minus 7 squared is equal to 0, then x minus 7 must be 0. And if we add 7 to both sides, we get x is equal to 7. So when when x is equal to 7, then we have a problem because what's inside the log will equal 0. Otherwise, this is just going to be a positive number, because a square is always positive or 0, and we know it's equal to 0 when x equals 7. So we just need to know that the domain is the set of all x such that x cannot equal 7. Because remember, this value inside cannot be 0. And if I write that in interval notation, I would go from minus infinity to 7, and then I would leave out 7 and then go from 7 to infinity. So this is the interval notation. Here we're going to take what's inside and set it equal to greater than 0, and now we're going to subtract 7 from both sides, and we get negative x is greater than negative 7. At this point, to solve for x, we need to multiply through by negative 1. And when you do that, you have to flip your sign. So this means that x is less than 7, because what I've done there is I've multiplied both sides by negative 1. And at that point, you have to change the direction of your inequality. So in this example then, finally, the domain is from minus infinity to 7, or it's the set of all x such that x is less than 7.